The topic of our project is making solar energy more economical. The members of the project are Mary Nguyen, me Tran, Ancel Furlow, William Vo, and Karla Solis. The purpose of the project is to find the most efficient solar energy panels while making it more affordable for the user. In the code, the user will be asked to select a country in which they want to calculate the potential solar energy production. The user will then have the option to choose from class of solar panel, land size, and power. They must also enter the cost per kilowatt hour. Based on the entered information, MATLAB will make calculations and output how much the user will save per year, depending on the type of currency used in the selected country. It will also compare it with how much more they utilize, and it will compare it to their current production.
Background of the NAE challenge for solar energy. As a source of energy, nothing matches the sun. It outpowers anything that human technology could ever produce. However, solar energy provides less than 1% of the world's total energy today, but it has much more potential than that. In this project, our team is going to evaluate a dataset which has the amount of solar energy used by different countries by certain amount of land from national renewable energy laboratories. We can look at and compare which countries are being the most efficient with their solar energy production and investigate how they use and attain solar energy in their country. There are going to be 4 equations for the code that we're going to use. The first one is the calculation to estimate the class of solar panel based on the input. So the class of solar panel equal the enter power divided by the enter land size, and the output is going to be the estimate class of solar panel. The second calculation is the calculation estimate the land size based on the input. So land size equal enter power divided by selected class. The output is going to be an estimate land size. The third calculation, we're going to need the user to input the cost per kilowatt. The calculation is going to estimate the saving cost per year. So saving equal cost per kilowatt multiplied by 30 and multiplied by 12. So the last equation is going to estimate the power. So power equal enter land size multiplied by selected class. The output is going to be the estimated power, kilowatt per hour.
Hi, this is my Tran. I'm going to present the algorithm for our group. Since the code is designed to find out the solar energy information about a country, we need to enter a name of a country as our first input. Any type of input will be validated, and so is our first input. If the input is valid, the user will be given a menu to select an option that they want to compute. There are 3 options in the menu: the available productive land size, the class of solar panel, and the power production. Depending on what option the user pick, it will assign the corresponding inputs. Generally, the required input for the chosen option will be the information of the remaining options. For instance, if the user wants to estimate the power production, they will need to enter the available productive land size and then pick a class of solar panel that are available in the entered country. After the input are validated, the code will execute the calculation using the user input specification to calculate the power production and then output the result into the command window. Next, the code will ask the user to enter the cost per kilowatt hour in the currency of the enter country, and then the code will do the calculation of the saving cost per year and output the result to the command window. At this point, the code will offer the user an option to study another country. If the user chooses yes, the program will start all over again from the beginning. If the user doesn't want to repeat the program, the code will ask the user if they want to collect the data. If the user wants to save the information, the code will save the information and output to the command window the confirmation that the data has been saved and also the explanation of how the data saved in the file. However, if the user doesn't want to collect the data, the code doesn't do anything and there is no output into the command window. And this wraps up our group algorithm. Next will be Ancel presentation.
Hello, my name is Ancel Furlow, and I will be explaining the test cases for our program. I'll simply be walking you through a few examples of how our program may be used. When you begin the program, the first thing you will be asked is what country you are working in. For these examples, I will be selecting the country of Afghanistan. Once you have selected your country, you will be asked what you would like to calculate: class, area, or output. For our first example, I will be calculating the necessary class for my entered parameters. When this option is selected, I will be asked how much power I'd like to output per day and the available area for me to cover in solar panels. The power I'm inputting for this one is 500 kilowatts. The available area will be 300 square meters. From these inputs, you are told that the minimum class of solar panel for this output, given the amount of area, is a class of 1. For my second example, we'll still be using Afghanistan, but this time we'll be calculating the area that we'll need to coat in solar panels. When selecting this calculation, you'll be asked how much power you'd like to output and the class of solar panel you will be using. For this example, I again put an output of 500 kilowatts, and the class I selected is a class of 4. With these inputs, the program tells me that I will need 118 square meters of solar panels to get the desired output of energy. For my third example, I will be calculating an estimation of how much power you can output with a given array of solar panels and class. Once I've entered my area in square meters and the class of solar panel that I'm using, I'll be given an estimated power output in kilowatts. For this example, I will again be using the country of Afghanistan, and for the area, I'll be putting 50 square meters, and for the class, I will be selecting a class 5. With these parameters, my estimated power output is 238 kilowatts. Once I am through performing my calculations, I will be given the option to save. If you save, you will be given 2 arrays as an output. One array will be a vertical array of 1 column, listing the countries in order from top to bottom that you use in your calculations. The second array will contain the numerical data. This data is made up of 3 columns, which include, from left to right, the area covered, the class, and the output for each calculation.
The limitations in our project is that there's no pricing information versus the class of solar panel to support the user in making educated decisions on which solar panel to buy. We also don't have information on how to find out the installation costs, so the user knows the difference between the saving and the installation cost. Because the installation cost was a little bit unpredictable, we couldn't verifiably have a certain installation cost per solar panel. Another limitation is that our data is not up to date. It is from a couple of years ago, and while the data is all valid, it's not modern data. So technology has changed, and we can essentially take the idea of our code and use data that's more modern to make it more relevant. And for the applications that we can use our project in is we can use it in websites and make it in, or we can make it into an app. to help people get the estimates of the right solar panel that they want, and they can change the variables on their own depending on their situations. With our code, we can look into the country that you want to know more about and know if it is being more efficient in their solar energy implementation. We investigated how they use and attain the solar energy in their country and show how much they can save depending on the different variables such as cost per solar panel, the amount of space they have, and the power. We hope that this can help to make solar energy a more attainable source of power without breaking your bank.